So usually I like to put all the diagram, all the force diagram on the picture. So you say, okay, we know there's a gravitation here and here. This is a mass M. Mass M. At the same time that the forces are pushed down. In which case this is mg. So mg is pushing down. So this is a vector. So now where's the motion along where the motion occurs? First, this object cannot move up, cannot move down, vertically in this case. Right? So only can move along this. In that cases, you have to mix. You have to determine what we call the axis. Where you determine the axis. Okay. So human beings are lazy, including since this is a more action axis, might as well determine this is the x-axis. So if you determine this as x-axis, then anything perpendicular to it, then that become y-axis. So this is a y-axis, and here is the x-axis. Now then you look at this. When this is sliding down on the y-axis, will this object move up? Will this object move up, or will this object move down? Okay, the answer to that is it cannot. Okay, depends on the force diagram. Unless there's a force go this direction, so might move it up, but the chance for it moving up, not in here. So the action is along x-axis. So you have to decompose these forces. So you decompose. So this decompose on along the x direction in this direction. Along y direction is in this direction. So there's two directions. So this is the x-axis direction, in which case this is the force pushing. In which case it's the F sub x along that direction. So preferably you want to draw it within this thing, so you will not be confused. So this is the F sub x. Okay, so you all of a sudden you define the F sub x, and then in here you have another direction, in which case is push it down, in which cases you call Fy. Now this Fy is pushing it down, but you know that this object is slide down, will not moving up and down. What does it indicate to you? There must be have some force to push it up. That I like to say is normal. Now in these cases, the normal force is in the future is important, not now, because that is related with the friction involved in the friction. Mg times, this is theta, mg cosine theta. So is mg cosine theta minus the another one is m. And now f sub x in the f sub x direction, in that cases is equal to mg is sine theta. The whole thing causes the motion it cannot balance. So this is equal to 0 because it cannot move up and down. And in this cases, this one is equal to MAX. So after you draw up this this is a diagram, it's called force diagram, and then you solve the problem already. Okay, so that is example 4.3. Now we like you to go to chapter 5. Chapter 5, there's a problem. It's almost similar like that. Chapter 5. Chapter 5, what we like to talk about is experimental experiment, example 5.2. So chapter 5. Chapter 5 is involve friction. That means something counter against the force to cause motion. So this one is drawn very nicely. On this example 5.2, in which case is something like this. Something like this. This is a slide. Okay, now there's a force adding up in here. Okay, and he says the following is a simple method of measuring coefficient of friction. Suppose a block is placed on a rough surface, inclined relative to the horizontal. Assume in this, the inclined angle theta is increased until the block starts to move. How is coefficient of a static friction related to critical angle theta at which the block diagram, the block just begins to move? Okay, so so here is have friction force F sub F. So the frictional force is dictated with the normal force pushed down on here. This is angle theta. Okay, so what is a frictional force? Frictional force is equal to mu sub s times n. So that is how you define the frictional force. So we like to do the same thing over again. Whatever happened to here, have something adding on it. So you have the same diagram. So look at this diagram. This is no friction, okay? But in here, there's a diagram. Now, again, it's the same. There's a force pushing down, in which case it's equal mg. And then at the same time, horizontally, again, this is in the x direction. And then on the top, this is the y direction. Okay, so there's an n there, Newton, is called normal force. This force pushes down, and that force n pushes up. This is related with the friction force. So when this force times sine theta, we have Fy in here is equal to around, sometimes you like to designate this Fx prime, Fxy. That is equal to mg times cosine theta. Okay? So you have a force diagram here. The force diagram on the y direction, summation of Fy is equal to minus n, in which case equal to 0. Because there's no motion on the vertical direction. This is the y direction, this is the x direction. There's definitely have a motion along the x direction. Okay, summation of summation f sub x equal to fx prime minus f sub f equal to max. So what is difference? Difference than this. In here is 0. Okay, this is the difference. Only one term. There's a friction. You see more. So that is the key for you solving your problem there. And then f sub f equal to mu sub n, and mu sub n is equal to, from here, the n equal to fy prime, that equal to mg cosine theta. So that is the case. So you can see the difference from this and this is basically is similar. You're just adding another components in the resistance force to the problem. Okay, any questions? Yes.